nice. All right. Hey, everyone. Welcome back to our 18th Core Devs call. I think it's been almost 2 months since we've been having these with holidays and busy January. It's been a while since this last public call. But regardless, there's been lots of progress, and we'll continue with these calls in 4 weeks. So for those that are joining us, you should know that the purpose of these calls are for core contributors to present what they've been working on, updating the community on what's coming, and brainstorm a little bit with the core working groups, task forces, and community members like you. So with so much happening, it's incredibly hard to fit everything into a 1 hour slot and have lengthy discussions. But so there's going to be time for Q&A after each topic. I'll try to keep track of time. And then you're highly encouraged to then go back to the forums, Discord, GitHub, and continue the discussions, reaching out to core developers of the protocol. Everything is out there in the open, so you're free to continue discussing this async. And we do want to hear your feedback and questions as always. So I'll paste in the chat and show notes also the link to the Graphs ecosystem calendar so that you can be subscribed to all future public core dev calls. And these are uploaded to YouTube. I don't think I mentioned that before. So I forgot to change my slide. That's pretty much it. I'm going to share the links. And now let's go quickly through the agenda. It's going to be packed one. So first, we've been talking about the graph network scaling on an L2 through Arbitrum, and we recently hit nice set of milestones. So we'll be hearing from Pablo and Nena, both from Edge and Node, on where we are currently with this migration and what's coming to products such as the Graph Explorer 2. So another big milestone for Subgraph developers and let's say data consumers in general is our support for file data sources. And Leo, also from Edge and Node, will go over this new feature. In the past, we've been having Adam going on to these calls, also explaining what this would be. We're now super close to shipping it, so we're gonna have a nice demo. Leo will go over these new features, support for off-chain data like IPFS and others. And we'll get to know when exactly this is coming to Graph Node. So thirdly, we have Soulbound Labs. This is a team it's a grantee that's been building on the Graph for quite some time already. And they will also be demoing a new paradigm called Subgraph Bridge, which essentially allows offloading of computation to the Graph network, while also bridging back the state to on-chain. So it's pretty cool. And Alexander is with us too, and is going to talk a little bit about it, explain it, what the value prop is, what the use cases it unlocks are, and also do a nice demo. And finally, Substreams. We've been talking about this for a while. Hey, Alex, this is truly a cross-functional effort by different teams, Streaming Fast, Edge and Node, Masari, the Guild, Pinax. I mean, pretty much all teams that have been working on this and different things like core functionality, tooling, development experience, docs, support for new syncs. There's plenty of stuff coming. And so today, I think this will be led by the Streaming Fast team. And we're going to take some time to hear all about the major milestones so far. And again, hopefully we'll have time to do some brainstorming, Q&A, and hear from you, community members, on what you would like to see next and your questions on all of this. So that's it. Let's move. Enough of me. Let's get into it. I think we're starting with L2, and that's Nena, right? Do we have Nena already on the call? Let me make you co-host, Nana. There you go. You should be able to speak and share your screen now.
All right, cool. Morning, everybody. I am just going to do a quick demo of the products. All right, can everybody see my screen?
Yep.
Awesome, cool. So what we are doing to enable L2 support in our products, so we already released it on testnet. So we have this network switcher that lets you switch the entire Explorer to Arbitrum Girly. And then you can access different subgraphs. So we have different things here. And if you switch back, for example, we'll take you to the Ethereum Girly subgraphs because it's different subgrid. The same with participants. Basically, on whatever page you are, you can essentially run the whole app in Arbitrum and see all the things that are going on there. In Studio, you can publish, let me find one of the subgraphs that are just deployed. You can publish a subgraph. Oh, something weird. The Zoom is slowing down the app. Let's try this one. Oh, maybe I just uncovered a bug. No, it's working. Okay, cool. Sorry, let me move this out of the way. So here you can publish, there's several options. And given that I'm an admin, I see these extra options, but essentially for now you can publish to Arbitrum Gorley in addition to other networks. So keep in mind, once we do Arbitrum 1, once this is all going to be essentially, there will be essentially another option in this dropdown, and the same switcher is going to show on the graph.explorer. So you'll be able to switch back and forth and publish your subgraphs to Arbitrum 1. I know this is a short demo, we're on a timeline, but please play around with it on testnet and provide feedback. We'd love to hear your feedback and any proposals for improvements. Thank you.
I've actually been getting some feedback from MIPS participants. I've been telling them to go back to Discord, and we have this Projects Explorer channel, I believe. Is that still the best place to collect feedback, Nina?
Yes, I think Ian is watching that channel, and we have other support engineers who are reporting to us. So yeah, we'll keep an eye on that.
Nice, cool, great, thanks. All right, so Q&A. Raise your hands if you want to ask questions. I'm monitoring everyone on the call. Whoever is co-host can just talk. Let's see if we have questions. Okay, nothing for Nana yet. Pablo, are you on? Thanks, Nana. Yeah, thank you. Co-host Pablo, there you go.
Hello, hello. Okay, so can you all hear me? Okay, cool. So sharing screen. Can you see this now?
Yes, full screen.
Okay, cool. So L2 updates. Just a brief recap on the whole plan. The idea is we're moving the protocol to Arbitrum because we want to allow it to scale. We want to have cheaper gas prices and so on. But we're doing it very carefully in several stages. I don't remember where we were last time we presented, but now we are on what we call stage 1. That is, we've launched the bridge and we've launched the protocol to Arbitrum. And then we're going to slowly start enabling indexer rewards on Arbitrum as well, and finally provide some migration helpers to make to allow protocol participants to move over to Arbitrum in an easier way. You've seen the products demo from Nena, and that means, you know, we've got the testnet stuff ready and coming soon, all of the production. So the Arbitrum 1 stage. On the contracts themselves, and this is maybe the meaty part of my update, that is, we've got the bridge and the protocol already deployed to Arbitrum. This happened in December. This means there is a fully working or almost fully working protocol there. And once we've done this now, obviously, you know, the products, as Nena mentioned, and all of the infrastructure around the on-chain stuff is taking shape. So soon we'll have the fully working thing with indexers actually indexing subgraphs on Arbitrum and so on. The gateway, oracles, everything else is slowly building up into having a fully working thing. And for stage 2, we need to enable indexing rewards. This is not straightforward. This is the diagram that I'm showing there. I'm not going to go into detail into how it works, but basically we're going to be minting GRT for the rewards on both sides. And this is GIP37, which you can check out in the forums if you want. The PR for that, all of the changes to the contract are ready. They've been audited. We're ready to go. We're just going through the formal testing to make sure everything works properly. and checking off all of the items in the checklist of all of the stage 1 testing, getting all of the infrastructure ready and the products and so on. And once that is done, we'll put this forward to the council for actually deploying these contract changes. And then finally, the migration helpers, that means, so we have the protocol on L2, we have the protocol on L1. Right now, if you're an indexer and you want to move your stake over to L2, you'd have to unstake, bridge the GRT, then stake on L2. And same if you're a delegator or a curator, you have to, remove the tokens from the contracts, bridge them over, and then put them in L2. And we want to provide easier ways to do that with maybe 1 or 2 transactions. So we've got the contracts for that. We've developed most of it. We're still doing some fixes and changes and trying to get that ready for audit. But hopefully we're going to go through that process soon and all of the testing and everything, so that soon after the stage 2 contracts are deployed and all of the product side is ready, we should be able to provide the migration helpers as well, so that people can actually move over to L2 in the easiest way possible. And then finally, an update on MIPS. Pedro has been leading this in a lot of ways, but we've been working together on getting the MIPS participants to actually try out the L2 as indexers. So right now, they are going through some missions on Arbitrum Gurley, and they are setting up the infrastructure, putting stake on the L2 testnet. They are even, delegating and allocating to subgraphs, serving queries and everything. So we're trying out all of the indexer infrastructure, or they are trying out all of their indexer infrastructure connected to the L2 testnet, and at the same time trying the product, so trying the Explorer. And all of this is providing great feedback on the products, the contracts, and everything, and it's helping us make sure that everything is working properly. We're hoping that soon after these missions on L2 testnet, we're also going to do missions on L2 mainnet, that is Arbitrum 1, so that through that, if things go well and the participants decide to stay there, we'll also be bootstrapping some indexers on L2, so that once we have the contracts and the products and the infrastructure ready, we also have some indexers actually serving subgraphs there. So yeah, that's all I have. Any questions? Or you can obviously find me in Discord as well in the forums.
All right, thank you, Pablo.
Thank you.
I see some clapping. Yeah, raise your hands if you want to ask questions so I can let you speak, or write in the chat. Okay, if there's no one, we'll move on to Leo. Do we have Leo? Yeah, let me see. Yeah, Leo is co-host already. You should be able to come online.
Okay, I'm gonna share my screen then. Okay, so I have a presentation, and then I'm gonna try to move quickly because I also have a demo. So file data sources. File data sources are a new feature which is shipping in the next GraphNode release to indexers on the network. And it allows you to sync data from files stored on decentralized storage networks into a subgraph, initially supporting IPFS files. So that's very requested, and it's great because we're known for being great for syncing on-chain data from multiple chains. But DApps increasingly have needs to incorporate off-chain data. So NFT, metadata, DAO proposals, social posts, all of those things are stored off-chain, of course, to save on gas costs. So file data sources delivers that for subgraphs, initially supporting IPFS, but it's designed to be extensible to supporting other networks such as Arweave and so on. There was like an sort of experimental support with an API called IPFS CAT, if you know what that was, but this is supposed to replace that because it offers more determinism guarantees, as we're going to see. And it's also just better overall. So this is like the architecture of how this works in GraphNode. So you have the data coming in from the chain. So you have a trigger, let's say an event trigger on Ethereum. And that's going to create a file data source based on the CID that's posted on the chain. And the file data source is going to poll for the file on IPFS, or if it was on any other storage network, it's going to listen for the availability of the file, because it's not guaranteed that STID can actually be found on the storage network. And once it is found, it's going to call the file handler with the content so that you can create your entities based on it. For determinism, there are a few restrictions to make, because you never know when a file is going to be found, right? Or the order in which they're going to be processed. But still, you need the results of indexing to be reproducible. So these are the rules and sort of limitations which are necessary to enforce that. So an entity that's created by a file data source is immutable. A file data source handler cannot access entities from anywhere else, from another file data source or from the on-chain data. And also like the file data source entities cannot be accessed by the on-chain data sources. So yeah, so that means like the data is pretty isolated, so that the data from off-chain data sources do not get mixed up in non-deterministic orderings. But even then, you still don't know if the file is available or not, right? So to get determinism around that, we're going to need some form of oracle for the availability of these files, which is a future design, a future step into getting full determinism for this feature. So let's go to the demo. So I've got here a subgraph, which is in this case syncing locally, but soon enough is going to be able to sync it on the network. And it's a subgraph for the purpose of the demo. It's for the Crypto Coven NFT DApp. So NFTs are a major use case for this feature. So the Crypto Coven DApp is about witches. So the NFTs are witches, and they've got nice little attributes such as the astrological chart, types, and so on. So we have a subgraph for that, which we have migrated to the new file data sources API. So what does it look like? So here you have your ordinary data sources from listen to the Ethereum contract for the Crypto Coven NFTs. And here this is new, right? This is a template of kind file IPFS. So this is the file data sources template. And it's going to be called this handle metadata handler whenever it finds the file on IPFS. So what the handler looks like, here we have the handle transfer for the NFTs tokens. So this is happening on chain. So if the token had never been seen before on a transfer, you're going to create here a new file data source that's going to listen to it, right? So there's that template that we just saw, which is a file data source template. And also cool here, you can see that it's actually accessing a file within an IPFS directory. So this is also supporting directories on this first release, a file within a directory. And it's a JSON file, right? So this is going to happen on chain. And you create this data source, but then this does not block the progress of the syncing of the subgraph. The subgraph continues to sync on chain normally. And then asynchronously, when the file is found, this handler is going to be called, right, with the contents of the file. So these are JSON files. So we're going to parse the JSON here, and then this contains all of the nice details of the specific NFT metadata. So in this case, as we just saw, the witches have a astrological birth chart, so you can get where the sun, moon, and so on. Yeah, so now you create these entities, they go into your subgraph, and now you can query them in the GraphQL API, the off-chain and on-chain entities together. And this is what I'm going to demo next, the queries. And this is cool because it also showcases another major feature which is shipping on the next GraphNode release, which is child filters, which has also long been requested, and it's also very powerful and plays very well with file data sources. So here I can query just sort of the list of all the NFT tokens. And here you can already see that I get the metadata, the witch name, and the astrological chart data, and sort of the basic token ID. And what I can do, I can filter this now using child filters by the properties of the metadata. So by those restrictions of the restrictions of the file data source determinism, I could not have all of these fields in a single entity, right? It must be split. The token metadata must be a separate entity, but that's not a problem because we can use child filters to query it. So I want to query here. I want to find all of the witches which have their sun in Leo, their moon in Leo, and their rising, whatever that is, in Leo as well. So, if I'm going to get a crypto coven witch, this is the one that I want to get. And I've probably messed something. Oh, yeah. So I just need to add this here. Okay. Still doesn't like it. Why not? Okay, I have a cheat here. I know where I go wrong, but well, the demo gods are against me. I just tried this a bazillion times. Oh, it's called IPFS URI, not token URI. Oh, okay, there you go. Aha. There you go. So these are all the witches which have the 3 astrological characteristics on Leo. So I can pick one of these. So let's say, Volcano, the raw missile. This sounds cool. So I can go here and just pick that witch by ID. And there it is. So now if you're building an NFT front end, you can integrate it with a subgraph, and you can have that super powerful search functionality by the metadata based on the centralized infrastructure, because it's going to be available on the decentralized network very soon, as we're looking to a new Graph release, or even for next week currently. And that's my demo.
That's really cool, Leo. Thank you so much. Pretty sure the NFT community will be super happy to play around with this. You said this is coming to GraphNode next week, is that?
Yeah, we're already in the process of cutting a release, so that's what we're aiming for.
Cool. I knew Simon would have a question. Simon, feel free to.
Hello, hi. I have multiple questions, actually. So the first one is, when are we?
Well, I don't think we have this is designed to be easily extensible. So if you've got a bunch of interesting use cases that users are bringing you, please do raise them so that we can prioritize RV support. It's meant to be a relatively straightforward extension.
Yeah, lens would be.
And here, Simon, I just want to add something, which is the foundation is also trying to RFP this particular Arweave integration, because it's, as Leo mentioned, it's super extensible, so it's easy to plug in other data sources, let's say, following this API. So if there's anyone that wants to do this work, please reach out to me.
And here you just switch that to like file/Arweave, and everything should work exactly the same in terms of API, right? Of course.
Yeah, it's done. Okay, there you go. Yeah, sorry, go ahead. Just wanted to plug that.
Okay, then what about arbitrary HTTPS data? Is it the same or?
Well, the thing there is that you have to have a plan for like how this is going to fit within, if we're going to have an oracle eventually, does that HTTP source make that more difficult? Is it aligned with the determinism requirements? So that, open question.
Okay, and then a use case I think that cannot be solved with the current implementation is it's very common for NFTs that we say like, for example, the Moon Leo, like only 10% out of, or like in a percentage of the total collection, how many have that particular trait? That would need to be stored currently on indexing time. I think it's almost impossible to do this on query time, but because of this cross references, that you cannot load another entity, it's hard to get that out.
Yes, definitely. Right. We currently don't have aggregations in the API, so you recommend that you do it like at indexing time, but these restrictions would basically impede you from doing it at indexing time. So yeah, that would be blocked. That sort of functionality would be blocked on a query time solution.
Okay, cool. Good stuff. Like I love that feature.
Very cool indeed. Thanks, Simon. You can lower your hand. I don't see any other raised hand. Okay, yeah, let's move on. Thank you so much, Leo. Super nice indeed. Alexander, Subgraph Labs, you up for it? Demo as well? Demo got a review. Yeah.
Let's hope. That's always the hope. So I don't have a nice PowerPoint or anything, but I'm just going to talk for a few minutes and give some background to this. So hi, my name's Alexander Gusev. I'm an engineer at Subgraph Labs. And together we built the Subgraph Bridge, which is a way to use subgraphs as a data source for smart contracts, as well as offload computation and use the graphs network as an L2. There were a lot of interesting technical problems we had to solve in order to build this. I'm pretty proud of the work that we did, and I'm super excited to show it off, as well as help people over the coming months build some cool stuff with it, hopefully. Also, before I kind of start talking some more, I want to give a special thanks to Adam Fuller, as well as the people at Semiotic, because they helped us quite a bit, answering some of the more lower level questions with GraphNode for generating some of the CIDs and whatnot. So yeah, a little bit of background. So I work for a company called Subgraph Labs. As Pedro said earlier, we've been working with and building on the graphs ecosystem for a little while now. And we're trying to build on-chain reputation tooling for DAOs. So this means tracking certain types of on-chain behavior, which can be defined by a DAO, and reward said behavior with either positive or negative reputation to determine voting power, for or against proposals, without using normal ERC20 token voting. And we found that subgraphs are the best way to track on-chain data to reward with said voting power. We even built a little no-code GUI to make building reputation subgraphs easier and more accessible for people. But there's one problem, which is that subgraphs are still technically off-chain. And so we needed a way to put them back on-chain. And so traditionally, you would be like, oh, okay, we want to get data off-chain and we want to put it on-chain. We should just use like an Oracle service, something like Chainlink or anything else. And those are fine, like those are a valid option for bridging data. However, we thought that there is a better way to do this because of the crypto economic security guarantees that the graphs network already has in place. And so basically we built a bridge which provides no extra cost for users to use to just access their subgraph data on chain with a few hoops to jump through. And so kind of the mechanism of the bridge, the way this all works is that under the hood, whenever an indexer serves a query request for the decentralized network, they include a signature in the response headers, which is a signature containing a hash of the specific request that they received, as well as the response data that they're serving, as well as some other pieces of information, such as the subgraph deployment ID and some other stuff. And so when you get this JSON blob, which is your query response, you also are getting a signed attestation from the indexer who has a slashable stake of GRT that they are attesting that, hey, this data is correct. And so this is very important because this whole attestation mechanism is the whole way that the bridge can work at all, because we use these attestations to open up disputes if people are serving incorrect data. And another important piece to note about these bridges is that bridges should not be made equally. The level of security that something like a DeFi protocol that is using a subgraph as a data source is going to be much higher than something, say, like a decentralized social media platform. And so all of these bridges need to be configurable to have, to basically sacrifice user experience for higher security or lower security for a better user experience. And so kind of the way that this works is a user creates a bridge and they configure these parameters like we talked about just a second ago, such as the response or the freeze period for responses that people are posting over. And then from that, users can then query according to the specific template that they generate. And I'll explain how that works and once I'm giving the demo here in a second. And then basically if the attestation is for the wrong sort of response or the wrong request, it'll reject it within the contract. And so you know that when somebody is successfully posting subgraph responses to the chain, Even if they haven't been formally accepted yet, they are from a valid indexer who has an eligible amount to stake, as well as it's the correct subgraph that you're specifically querying for. And then this freeze period begins, which is sort of similar to how optimism or any of these other optimistic rollups work, where there's a dispute window, and after this dispute window, it is free for anybody to free for anyone to use. And so I'll go ahead and share my screen now, and we can give a demo of how this all works. So let me go ahead and share my screen. Can everyone see it? This is our little interface that we have. Awesome. So this is a showcase of some subgraph bridges. And these are all specific query templates, which is how the specific subgraph bridges work. Right now, we're only deployed on Goerli. There is one issue that we need to solve regarding historical dispute data that I can get into in a second here, but we have some PRs open for that and we're making progress there. And once that is all handled, the subgraph bridge can get deployed to mainnet or Arbitrum or any of these other chains that are now supporting subgraphs through the MIPS program. So let's create a bridge. So the way to create a bridge is we click the create bridge button and we select which blockchain we'd like to make it to. And the first bit is we need to have a subgraph deployment ID, which is the subgraph that we're actually querying from. And so we can go over here to the testnet subgraph explorer and find some subgraph if it loads in a second. So for instance, we can say whatever this one is. The subgraphs are a little bit odd on Goerli, but that's just because it's a testnet. So we can copy and paste this deployment ID over here. And now the way that this all works is that for each bridge a user creates, you have to specify a query template. And so how this works is if we want to make a query, let's say in the case of reputation DAOs, we want to get a Merkle root containing all users who should be able to claim a certain type of NFT, which represents their voting power, let's say. We could do this in the subgraph by generating a Merkle root and then using a specified query to get the latest Merkle root for a specific block hash. And this is another important piece of the query, is that it must contain the block hash specifier. We use block hash to prevent against reorganizations, messing up the query results, and also to add deterministic query results, because subgraphs are deterministic. And so the request identifier that you have for a query at a block hash or a block number will always be the same, as well as the response data should ideally always be the same, unless an indexer is serving incorrect or bad data. And so for here, I already have made a couple ones for this subgraph. And so we can grab some factories and we can grab, let's say, the first two or something, and we can get the DAO count, let's just say. And so we can see our thing works. There's actually only one field called DAO count that has a value of 6 right now. And so then we can go on to move to configure this slashable stake. So this is a security parameter that you can choose to say basically how much an indexer has to be eligible to lose in order to provide data for here. So the lowest possible is 100,000 self-stake GRT, which is the minimum to index in general, and it can go as high as 5 million if you want to. The number is arbitrary, so you could set it to 500 quadrillion if you really wanted to, but I'm not sure that you would have many indexers serving subgraph data for you. And then finally, you just select the dispute window. And so this is how long this proposal freeze period is. Because of the existing crypto economic guarantees, subgraphs have a very low percentage of bad requests. And so where security isn't the utmost concern, immediate finality is more than acceptable, because again, we do all of these checks in the smart contract itself to prevent people from spoofing it or serving data which didn't actually exist in the subgraph. It does a lot of checks under the hood to make sure that the data it's receiving is coming from an indexer, the signature is all valid, et cetera. And so the dispute window is there to determine how long people should have to wait. And so I'm not going to worry about sending transactions or anything, because I don't want to have to deal with that awkward UX when we're giving this demo. And so I have this pre-made one. So we can see I have submitted a couple different responses here. So once we create a subgraph bridge, for the specific query, we can go to submit a response, which will execute the query for whatever current block we're on, as well as the block hash. And we can, try and submit this response here to add it to this list once that transaction gets accepted. And then once the proposal freeze period is finished, we can then certify the subgraph response. And so right now, there isn't any sort of issues because we are receiving the same data for all of these different requests. And also, I guess all these different requests are for different block numbers, but if they're being requested at all of the same block number, it will check to see that this queue of proposals that have been made for the specific query all have the exact same hash of their contents. And if it doesn't, it automatically opens up a dispute for the Graphs dispute manager contract and says, hey, look, this is not good. We don't want, these should be the exact same query response. Let's figure out what's going on. And then finally, once that has been settled, it is eligible to be certified and the incorrect proposal is removed from the queue. And so to certify the subgraph response data, we just go ahead and click certify, which then we can send the transaction. I'm pretty sure you guys can't see my MetaMask because I'm only sharing Brave, but I'm not actually sure. And so again, like we saw earlier, the DAO count should be 6. And so if we grab the Subgraph Bridge ID over here, we can go to the contract and we can check the latest Subgraph Bridge data for this contract or for this Subgraph Bridge. And we can indeed see this is a bytes encoded 6, which is the correct value from our subgraph. And so we have successfully created a bridge, specified a query to bridge that data on. We bridged it, got the attestation from the indexer, and then used that data, which now we can use freely back on chain. And so that's kind of more or less the end-to-end demo of how this works. All of the code is open source, and we have pretty good documentation online at solonlabs/subgraphbridge. And then, yeah, does anyone have any questions? I think that's everything more or less that I wanted to, that I kind of wanted to share, I think. Let me check my notes. Yeah, that should be good. So does anyone have any questions?
I guess our heads are still spinning a little bit, Alexander.
Sorry, yeah, I don't know. Also, if that was faster, you want me to like change anything or go over anything in more detail, I'm happy to. There's kind of a lot of data to digest there. So I apologize if that was rather dense.
No, it's good that all of this is recorded. We can always go back. Like I've seen this probably 3 times already, but there's always something new and there's a lot going on there, but it's extremely interesting. I guess, did you cover what sort of use cases you're aiming for? You said reputation, right?
Yeah, so as far as use cases go, I think some of the obvious ones that come to my mind are offloading computation and also having kind of dynamic data sources. So for reputation, this is particularly nice because if we are defining a set of sold-out NFTs, which can be used to represent voting power in a DAO, we can define how those should be tracked in the subgraph, and then we can Merkleize all eligible users and put them on chain, and then we can have a static fixed piece that updates as the subgraph indexes. So anyone can bridge this subgraph bridge data over because we specify this query, and if it passes all the security checks that we have, it's eligible for use. So there's no sort of like manual overrides that need to be done. There's no admin control that has to be done. We can specify how this should be done, how these reputation badges should be awarded, and we can mint them out to people. I think that it's also pretty interesting as well. I think Merkleization is a pretty powerful primitive in this sort of use case because you can do a lot of cool, weird computation in the subgraph that it would kind of be unfeasible or perhaps even impossible to do on chain in any sort of gas efficient manner. So yeah, the first one that comes to mind though, obviously is reputation or any sort of batched grouping that you want to use as a subgraph. Actually, that's not entirely true. There is one thing which I think is very powerful. This technically does enable composable subgraphs because you can use subgraph responses which do get emitted from the subgraph bridge itself. So you can actually use subgraph bridge data as a source. So you can kind of have weird composable subgraphs without needing composable subgraphs because you have subgraphs which are being bridged back on chain. So that's actually another really cool thing I'm excited about.
Yeah. It's all about Legos, right? If the data is on chain, you can do stuff like we've seen with DeFi and these money Legos, but bridging all of this stuff on chain and then just unfurl the Merkle roots or whatever, it's pretty cool.
Yeah.
Raise your hands if you want to ask questions to Alexander. If not, we'll move forward. And we're right on time. Super happy. No questions. Cool. You know how to reach the Soulbound Labs team. Yeah, please feel free to share all of the links you just mentioned here, the GitHub repo, the docs, so people can then take a look. And I'll also add it to the show notes. Okay, I see Alex is leaving, so I'm going to call him out. Alex, you ready for Substreams? Yeah, thanks, Alexander.
Good morning, the graph. So I wanted to just show a few things and a few news because it's been a while since we've synced up about mostly Substreams I'm going to do around. There's been a lot of improvements to the documentation. So you can take a look at this website here, substreamstreamingfast.io. Been revamped quite a bit, a lot more information, references, and stuff for you to consume, okay? And one important thing that we added there is the production mode. So you have in the changelog here all the details of what it means to have production versus development mode. I want to give you a quick overview of that because that was, you know, the promise of Substreams was to synchronize the chain 1,000 times faster. Okay, that's the goal. And prior to like a few weeks back, we had done parallelized processing of the history prior to the point where you're streaming. That would mean if you want to stream at block 12 million, we would do parallel processing for everything before, but then it would be linear. Okay, but that's not how the graph node expects information. The graph node, for example, if we want to have subgraphs, needs to have forward processing. We want to stream everything. So that's what we did. We implemented, we call that forward parallel processing, meaning you can start at the beginning and the work is being done in parallel while you're streaming out everything that's coming through as fast as possible. Okay, so production mode also means that we've made a few more constraints to make it fast. You can only specify one module, a mapper module, as an output thing now. And if you're in development mode, there's a few things that change now is that we will send you all of the modules outputs plus logs. They're now debug output stuff. You don't rely on these things for production. Production, you rely on the output of, you know, only the mapper module you're interested in. Okay, so that's a shift. And I want to demo you a little thing that I haven't even shown to the team here, a GUI I've been prototyping that shows the production mode like on steroids. Let me show that to you. It's like it's half baked since yesterday, okay? It's not done, so you'll see it's really quirky. But this is a new function you'll get on the GUI here, on the Substreams command line, GUI, and it'll open that little thing here. Hopefully that works. I don't know if you see that. This is like processing in forward fashion, and you've already received payloads. You know, see that? This is streaming out to you as fast as possible because it's probably using the cache or using parallelized, you know, engine that's once it's done, you get a batch of blocks. And eventually when you have the parallelized engine that's covered the blocks you're after, it would just saturate your pipe like that. And I don't know if you're looking at here, but we're seeing the GUI in action. Okay, eventually we'll have a view of the request. We have the progress tab, which is the thing you normally see. Let me show you, you know, the simple one. You normally see when you're processing. Okay, let me show you with the graph out here. So we'll have a bunch of modules. See, that's really cool to see. It's going in parallel. It's doing a lot of work on different modules. 600 blocks per second here. So you're used to that, but now you can switch to the output view or back to the progress view with the tab key. Isn't that neat? Okay, and then the simple demo here, you'll see that you can have outputs and you can also navigate between the modules. Look, you see you have the factory module here, and with the key U and I, you can switch from module. But that doesn't change the block at which you're looking at things. This is the block navigation, which you can also change here. I'm hitting the different keys here. So you can see for a given module, the output at a different block, right? And if you switch the module, you keep the block at which you were at, keep the context. So you can independently switch from modules. And over here, you have the logs and you have, the output of the thing decoded and all the bells and whistles, all the while progress is happening perhaps on your forward processing. Okay, so that's the GUI. I think it can be really helpful. I want to also wire that sort of replay so you can save your session on disk and reopen it without even hitting the server again, just going to explore that data with its facet. So the GUI is coming to a home nearby. Now, next thing is we've done a lot of work also on the graph node integration. Oh, so by the way, if you have questions right now or for the thing you just saw or things that are coming, please drop a comment in the chat so we don't wait for your questions. Drop them right away, okay?
Post in the chat right away. Sorry, Alex. So if you wanna do that, raise your hand. I'll then let you write.
Okay, so you do that. If you have a question, you raise your hand and you can write about it. So we don't wait for that again. Okay, yes. So what we've done also is wrap up the integration for Graph Node. Means that Graph Node now supports Substreams-based subgraphs. So you can use the parallelized engine of Substreams to push data into subgraphs. There's no assembly script that needs to be written in the subgraph side of things. It just pushes everything into Postgres, and then you have the query layer that you know and love already. It's available. So we have done some work there, and we've synced Uniswap v3 with that. We had prototype and all that. And we've done that in 86 hours, correct? 86 hours. So that's without a bunch of optimization that are still to come, but still a thing that would take normally many weeks now was able to be synced in a few days. And we're going to make it faster even. So that's it. And so that should come out very soon. Someone might say something about, the release schedule there, but it's all bolted into Graph Node and it works. Now, another thing we've done that we helped clarify, some people were using Substreams, the store modules, thinking of them as the place they would end up querying their data. But that's not the proper model of Substreams. Substreams is this transformation layer, and the stores are there for transient information because you want to do some aggregations and stuff like that. It's not the place where you want to query your data. You're not going to put terabytes of things in there. So to make it clearer, we developed a thing we called the sync KV. It's a key value store to synchronize. Let me show what it is here. It's another process that allows you to consume a certain SPKG from a certain endpoint and load the data into a larger scale key value store. So it's one of the syncs. Our goal with the Substreams engine is to have multiple syncs, one of them being Graph Node. And this one is another very simple output, much simpler than Graph Node. It's a dumb key value store. And what we've done right now is that we made it available. So you run that thing, it syncs it in the key value store, but it also acts as a small server. And you can query from the web using, I don't know if you guys checked Connect Web and Connect Go. We're using a lot of Go here. Connect Web allows you to use gRPC services directly in the web browser in a way that does not suck. And it's built by the guys at buff.build. So if anyone uses protobuf, check out Connect Web and their stack there. It's sort of an abstraction similar to gRPC Web. Anyway, so we're offering that little service so that web users can query the key value store directly by getting one key, by a prefix search, by scanning or whatnot, and you get responses as if you were very close, but it's not SQL, it's not GraphQL, it's, you're querying the key value store. So that's out. It's being used. It can load the data at massive scales because it's a very simple thing. Key value stores, normally you can augment the throughput because these stores scale horizontally pretty well. It supports Badger, which is a disk-based thing. It supports also TIKV, which is TIKV is a on-prem key value store built by the Pink Cap guys. It's what backs TIDB, which is a MySQL horizontally scalable MySQL drop-in replacement. And so TIKV, and also Bigtable by Google, the thing that backs, Gmail, things that scale massively, you can write, at massive speeds. Okay, so that's for the KV. But we have also done a MongoDB sync, a thing that takes your output for Substreams and just drops into Mongo, and also a Postgres sync. But just before, I'm really amazed to see that also Sebastian has rolled out a ClickHouse sync. So you take the Substream, same code, but then it puts that into ClickHouse. And I know the guys have worked also on dropping that on disk and files to load into BigQuery and other data stores. And some folks at Messari are working to transfer the data from Substreams into Parquet file to load it in yet another bunch of data stores. So slowly we're seeing the ecosystem around Substreams grow in power. And now it becomes very tempting for layer ones that are looking at all the benefits they would get to say, oh, if only we integrated the Firehose instrumentation there, we would get all that machinery for free, all the syncs. So we want to grow that ecosystem of syncs, and we want to roll that out, as fast as possible. All these units of deployment like this one as services on the decentralized network. So not only Substreams on, as a service there, but also a deployable unit of a KV, which contains a reference to, a SPKG. And I want to share just a little bit a vision about, you see that interface here that I've shown you, the get thing, right? For reading. This is a custom, it's a very raw, rudimentary, interface to the key value store. It means the front end needs to understand the layout of your keys, which might be annoying. So what I'm imagining in the future, and we've been thinking about that, is that these little servers would be deployed not only with a Substreams package as a source, but also as a WASM, including a WASM that acts as the server, in which you could define random and custom formed gRPC or GraphQL or REST, interpreters that would then turn around on the server and query the key value store to do all sorts of crazy operation to package the data for responding to end users using, a custom thing. So I'm imagining deployable units of WASM for query, which would be something similar to, custom resolvers you could imagine in GraphQL land. And on the query side, internally, the WASM would have access to the key value store, but then also take that same little box there and put it on the Postgres sync, where on the other side, you can choose the interface you're designing and offering to your end users as deployable units. And internally, you have access to Postgres to do all sorts of wonky queries. So that sort of other deployable units would mean that this full ecosystem would flourish and, responding really to all the needs that I can still see. Like you have a store, you have custom query layers, you have powerful, real-time and parallelized processing engine for history. Select the sync in the middle for your use case. I'm not sure there's anything left in big data land that would not be satisfied by these things. So I'm pretty excited by where we're at, where we're headed. If you have questions, I would love to answer them. And you raise your hand right now, you send a question, otherwise stay silent forever. Oh, come on. Okay. Well, in any case, thank you.
Wait, there's some.
Denny, come on.
I got to add something there. You missed out a Prometheus sync, which would be pretty nice to have. So that I think there's a lot of syncs that can get out there, but a Prometheus sync, something that we're working on. So.
Oh, so EOS Nation has another sync who's a PNAX.
Yeah.
So to sync and add metrics to it. That's very interesting. Congrats. Let's put that on this. We'll have that in the docs right now. Only the KV is documented there. We'll want to wrap that up. Okay, so if you want to follow out, Yaniv, go ahead.
Really great demo. Exciting to see the Uniswap substream synced. What's the latest on adding substreams to the network? And I think, we have talked about wanting to support different I guess, databases, data stores, didn't think it would happen this fast. It's cool to see already these different syncs. And I guess there are plans to support, these different types of services on the network. So what's kind of in progress there, and what do you see coming up?
So progress is we've designed a way for Substreams as, a streaming engine to be made available on the network, and probably unit economics would be, you would be billed by the bytes, read. This is closest to the way the costs are structured on Substreams. So, back in the retreat there with Yanis, we've designed and sort of came up with where these things would fit, how they would be exposed on the network with sort of, unit of deployment that would be shown on chain. So that's been designed. There's work to be done and scheduled. That's not fully complete, and we need to make some efforts now there to figure out who's going to take on that ball. And yeah, there's a GIP that's been started there to add additional services. So that's for the Substreams and Firehose services. And then we'll need to work a little bit more. Like the KV is just released last week, so we don't need. And the goal is to put the ball rolling, right? Now that it's there, we're going to need to design and think through what it means and how we reel it in. So, I mean, it's going to be exciting. There's some work to do, of course, to bring it to the decentralized network, but it's planned, and it's being planned more and more.
Yeah, so that's going to be huge, and is really going to expand the scope of the sorts of things people can do on the network. So hoping that different folks in the community, I think, it's going to touch a lot of different people. Developers are going to have a lot more things they can do, and indexers will want to support these different things. So please check out the forum and participate in the GIPs as we're discussing how to bring this stuff to the network.
Absolutely. And in the meantime, we'll also be releasing more docs on the graph node integration, so people can also test it on the graphs testnet, hopefully to get a first glimpse of how they could still leverage the graph node, the GraphQL interface, and then just use the substreams as, as Alex was saying, just as the transformation layer. That could be also a nice first step. All right, I think we're at the top of the hour, perfect timing. Last call for questions for Alex or anyone else, really. Okay, not seeing anything. Again, keep it up. You can find us on Discord forum, of course. Let's continue the discussion, and we'll see you all in four weeks. So thanks for all of those that came on and did these nice demos and quick updates. And yeah, pretty cool. Thank you all. See you.
Thanks, everybody.
Thank you. See ya.